Yeah. Now let's see Range-Kutta method of order 4. So consider the initial value problem dy by dx is equal to f of x comma y, where y of x naught is equal to y naught. It is the same first order differential equation with the initial values x naught and y naught. We have to find y of x naught plus h, where h is nothing but the step size. Same as the previous one. Previous problem x naught is 1, h is 0.1, so 1.1. So we are going to find the y value at 1.1, same. So here the difference is we are going to find 4 slopes, that is k1, k2, k3 and k4, and finally we are having this formula. Okay. First I will explain what are these. So k1 is nothing but h into f of x naught y naught, and k2 is h into f of, now I am not calculating at x naught, I am finding the value at x naught plus h by 2 comma y naught plus k1 by 2. We are using the previous answer. So remember, checking procedure, first find k1 and check whether k1 is correct, then go for k2, because if you found that at last after finishing k4, if you found that okay k1 is wrong, then you have to change everywhere. So please be careful with the formula. And k3 is h into f of x naught plus h by 2, this value is same, and y naught plus k2 by 2, that is this answer, k2 by 2 we are using, and k4 is h into f of x naught plus h comma y naught plus k3. So x naught plus h means automatically that is your value at which you have to find out, right. So we are in the final one only we are having x naught plus h comma y naught plus k3, and coming to this formula y of x naught plus h is equal to y naught plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. Okay. So if we are taking average of some 4 slopes, then we will write by 4, correct. Why we have written by 6? This is nothing but weighted average. Check the coefficient 1 here, coefficient of k2 is 2, k3 is also 2, k4 coefficient is 1. If you add all the coefficient 1 plus 2 plus 2 plus 1, 6, that is why we have written here 6. So this is nothing but weighted average of these values. So keep this in mind, and one more mistake normally students tend to do is they will write h over here. Already we have included h in this formula. So we are going to find k1, k2, k3, k4, and we are giving more weightage or more importance to the slopes 2. That is why we have written 2. Here weightage is 1, here also weightage is 1. So 2 k2 and 2 k3 we have given. So we have given more importance for the slope k2 and k3. Okay, now let us see an example. Yes. So given dy by dx is equal to 3x plus y by 2, y of 0 is equal to 1. Compute y of 0.2 by taking h as 0.2 they have given. Okay. So by RK method of 4th order, also find the analytical solution. So your initial value is 0. Okay, from there you are going to find at 0.2. What is the difference between these two? 0.2. So they have given directly h is 0.2. So it means it's a single step stage method. It's easy for us. Okay, if they have given 0.1, then what you will do from 0, you will find y of 0.1. and then use that as an initial value to find y of 0.2. 2 stages we have done. So here good that they have given h is 0.2. So we have only one set of formulas, and k1 is nothing but formula is h into f of x naught comma y naught, and your h value is 0.2 into f of x naught comma y naught, that is f of 0 comma 1. What is my function? My function is 3 into x plus y by 2. So 3 into x value is 0. Here x is 0, y is 1. 3 into 0 plus 1 by 2. That is what we have written. Simplify this and you have got 0.1. Now k2 is h into f of x naught plus h by 2 comma y naught plus k1 by 2. X naught value is 0 plus h value is 0.2. So we have written 0.2 by 2 plus k1 y naught plus k1 by 2. So y naught value is 1, plus k1 is your previous answer. As I told you, if this is wrong, everything will go wrong. So please check this answer and then substitute. So 0.1 by 2. And when you are writing, this is x comma y. Okay. So you have to write comma here in between. So x plus h by 2, y plus k by 2. This is the format. And after simplifying this k2, we have to substitute the values, right? 0.2. So this simplification is 0.1. And 1 plus 0.1 by 2. So 1 plus 0.5. So we have got 1.05. So your x value is 0.1, y value is 1.05. What is my function? 3 times x plus y by 2. What is given in the question is our function. So 3 into 0.1 plus y by 2. So simplifying, we got 0.16825. And then we are going to find k3 and k4. And k3 is h into f of x naught plus h by 2 comma y naught plus k 2 by 2. So x naught value is 0 plus h by 2 is 0.2 by 2 comma y naught value is 1 plus k2 by 2. k2 by 2 is your previous answer, that is 0.165 by 2. So we are going to simplify this. So we will get 0.1. This is same as the previous one. So you can write it directly. So you have got 0.1 and 0.165 by 2 plus 1 will give you this answer, 1.0825. Okay, so very rare students will do mistake in board mouse also. You should not add 1 plus this and then finally divide by 2. So first you should do the division and then only you should do the addition as per the board mouse rule. So 0.2 is there as it is. Then this is my function, 3 times into x value plus y by 2. And we got this answer, 0.16825. And if you notice, I told you to check your answer twice thrice, right? Your k1 value, what you have got is say 0.1 we have got in this problem, and k2 is 0.165, k3 is 0.16825, k2 and k3 will be almost close. And when you are truncating the last digit, please be careful. Okay, write up to 4 digit, and 4th digit you should truncate it depending on the 5th digit. Always this is a rule in the numerical method. So for example, I will say after this 5 there is 1, I will write till 5 and leave it. After this 5, if there is 7, then I will write the last digit as 6, 0.16826, like that I will increase 1 digit in that. So truncate the last digit properly, otherwise all the answers will look similar. And finally coming to k4, h into f of x naught plus h comma y naught plus k3. So x naught plus h is nothing but 0.2, 0 plus 0.2 comma y naught plus k3. Okay, so y naught is 1 plus 0.16825, so 1.16825. This is easy. So finally 0.2 we are writing as it is. What is my function f of x comma y? 3 into x plus y by 2. So 3 into 0.2 plus 1.16825 by 2. Simplifying, we are getting 0.23685. So far we have got 0.16, right? Now we have got 0.23. Now finally, what is your y naught value? Y naught plus 1 by 6, k1 plus 2 k2 plus 2 k3 plus k4. So we have got k1, k2, k3, k4, just substituting all the values over here. And when you are simplifying, you are getting 1.1672208. I told you to truncate, right? So for example, I am writing 4 digit means after 2 we are having a number. If it's number less than 5 means I will write that as it is. So we have written 1.1672. So this is your approximate solution by RK method. Now if they ask us to find analytical solution, same, it is of the form dy by dx plus py is equal to q. And it's very obvious in your question, dy by dx plus py. So we want y coefficient, right? That plus y by 2 on, if I take it to the other side, I'll get minus y by 2. So minus 1 by 2 is p and q is 3x. And this is the solution, y into e per integral p dx is equal to integral q e power integral p dx dx plus c. So, we will first find e power integral p dx separately. So, as I told you, this y by 2, if it comes to the other side, it will become minus y by 2. So, p value is minus 1 by 2 and q value is 3x. What we have to find? E power integral p dx. E power integral minus 1 by 2 dx. Dx if you integrate, we will get x. So, we have written e power minus x by 2. Your solution is y into e power minus x by 2 is equal to 3 is just a constant, I have taken it outside, integral x into e power minus x by 2 dx plus c. Okay. And this is easy, integration by parts on the right hand side. So, this as it is we are writing, here as it is we are writing, and x into e power minus x by 2. So, this is nothing but integral u dv. So, I have written the same thing again here, integral x into e power minus x by 2 dx, and so you are going to take x u as x, therefore du will become dx and dv is the leftover thing e power minus x by 2 dx. So, we from dv if we want we have to integrate. So, integral of e power minus x by 2 dx. So, if you integrate this, the constant will come to the denominator. Along with x, what is a constant? Minus 1 by 2. Don't leave the negative sign. So, minus 1 by 2 will come to the denominator. So, minus 1 by 2 if it goes to the numerator it will become minus 2 e power minus x by 2. And this is the final formula, integral u dv is equal to uv minus integral v du. And how we are selecting u and dv? So, isolate rule also you can go for it, or if I differentiate, the term will vanish, means that is going to be u. So, x if I differentiate, it will become 1 and then the next step it will become 0. So, u is nothing but x. Now, we are just going to substitute these values in the final formula, and hence if you see uv minus integral v du. So, if you see this step, 3 is already there, okay, outside the integral. So, 3 is there as it is, and then uv, x is u, and then v just now we got it as minus 2 e power minus x by 2 minus integral minus 2 e power minus x by 2 du. So, differentiation of x is 1, so we have written 1 dx plus some constant c. So, finally, we are simplifying this, okay, just pushing this minus to the front. So, minus 2 x e power minus x by 2, and when we integrate this value, 1 more e power minus x by 2 by minus 1 by 2 will come, okay. So, we have got minus 4 e power minus x by 2 plus c, and sign is this minus and this minus is plus, but in the denominator 1 more minus 1 by 2 will come, right. So, again we will get a minus here, that is why we got 4 here, 1 2 and then denominator 2. It is just a simple integration. And now what we are going to do is this e power minus x by 2 I do not want, okay. So, multiplying with e power x by 2 we get, so automatically this will become e power 0. So, I will get y is equal to minus 6 x minus 12 plus c e power x by 2. So, we are multiplying with e power x by 2 to get y is equal to something, because that is our solution, right. And now what we have to find? C. So, to find C, what we will do? We will use the initial condition. In the question they have given y is 1 at x is equal to 0 initially. So, wherever x is there substitute 0, wherever y is there substitute 1. So, 1 is equal to 0 minus 12 plus c. So, we got c as 13. So, this is our solution, y is equal to minus 6x minus 12 plus 13 e power x by 2. Now, we know we have to find the value of y at point 2, right. Substitute that, wherever x is there substitute 0.2, 6 minus 6 into 0.2 minus 12 plus 3 into e power 0.2 by 2. So, substituting these values in the calculator, please be careful, these two are negative. So, add these two and then put a negative sign in the front, and this is positive, and finally your answer is 1.1672219. And again truncation, as I told you, after this 2 we have 2, so we can write it as 1.1672. and if you notice that your analytical solution and approximate solution are exactly same in this case. Okay. So, RK method is very easy, but please be careful with the sign. Okay. And try to solve this problem on your own. X plus y is into dy by dx is equal to 1. Y of 0.4 is equal to 1. Yeah, now you can see this is your initial value. X plus y into dy by dx is equal to 1. Y of 0.4 is 1. So, you want dy by dx, right? Push this to the other side. So, 1 by x plus y is your dy by dx. So, it is easy for you to solve it. And y naught is this 1. X naught is 0.4. So, we have to find y at x is equal to 0.5. So, what is going to be your h? Guess your h. H is nothing but always the next point, right? The difference between the previous point and the next point. So, they have given that x naught plus h is equal to 0.5, correct? So, h is equal to 0.5 minus x naught. So, 0.5 minus 0.4, that is 0.1. Always x naught plus h is at which you have to find the value, because they have asked find y at x is equal to 0.5. So, I have written x naught plus h is equal to 0.5. X naught is my initial value, substitute that, you will get h. Or else you can say given point is 0.4, what we have to find is 0.5. Okay, given point is 0.4, right? This one they have given. Y at 0.4 is given. They are asking you to find y at 0.5. So, what is the difference between 0.4 and 0.5? 0.1. So, your h is 0.1. So, you have to find K1, K2, K3 and K4 and use the formula. K1 value is 0.0714 and this is the solution. We have just applied the same formula. K2 is 0.0673 and K3 is 0.0674, K4 is 0.0638 and finally y at 0.5 will give you 1.0674. So, all problems in RK method, in all the numerical methods are easy, and we have to be careful with the silly mistakes, because if we do a mistake in K1, that is going to affect the entire problem. So, practice a lot and try to finish the problem on time. Thank you.